Samsung buys two more high-end NA EUV machines. Samsung is reported to be paying $773 billion for two high-NA EUV machines, the TwinScan EXE 5200B, with one for delivery this year and one for delivery in the first half of 2026. Samsung already has a high NA EUV tool for R&D use at its Hwaseong facility, which is where the two new high NA machines will also be installed. The two machines will be assembled as part of production line and go straight into supporting 2nm support foundry processes and the manufacturing of a high-end logic products like Exynos processor and Tesla's ADAS chips. Although the assembly of the Intel High NA machine took 8 to 9 months, ASML has accelerated the assembly process in subsequent iteration. Each machine has the capability to produce between 185 and 20 wafers per hour, which will substantially increase Samsung 2nm output. They can fab transistors down to 8nm with a gate pitch of over 40nm and a metal pitch of 20nm. TSMC says it will not use the high NA for 2nm process, but it will bring it into the production line at a succeeding 1.4nm process. The company has a high NA machine which it is using for research. Earlier this week, Qualcomm and MediaTek both said they were looking at moving over to Samsung for 2nm foundry because TSMC's high price, said to be $30,000 per wafer. Apple M4 chips smashes Snapdragon X2 Elite in early single-thread benchmarks. Single-core cores scores rival Intel's Core Ultra 9 2585 kilo and beat the AMD's 9950 X3D, teasing multi-core potential of future variant. When you purchase through links on our site, we may earn affiliate commission. Apple unveiled the latest addition to its family of homegrown chips, the M5, a couple of days ago, and is powering both the new iPad Pro and the 14-inch MacBook Pro. The new Geekbench listing spotted by TechInfo revealed that the performance in single-core scores is enough to rival Intel's Ultra 9 285 kilo and bridge past AMD's 9950 X3D. As is to be expected, it struggles in multi-core against those models, but the results show the potential of Apple lattice silicon and their surely inevitable Pro and Max variant of the new chip. The MI iPad Pro scores 4,138 points in the single-core test, outperformed by the M5 MacBook Pro, which scores 4,263 points. That's not too bad, but the real jump is observed in multi-core result, where the M5 MacBook Pro scored 17,862 points versus the iPad 16,366, continuing a 9 difference in the performance. That with the same 10-core based configuration on either device, but the MacBook does not have activity cooling and a much thicker chassis that can prevent thermal throttling and allow the chips to boost higher, sustaining that for longer periods of time. It's easy to see what the fully fledged Pro laptop would outperform thin, albeit overkill tablet enough those they carry the same quality silicon under the hood. Apple never actually discloses clock speed numbers in each tech spec, but in the Geekbench listing, we see that the iPad Pro M5 ran at 4.43 GHz, while the MacBook Pro M5 topped out at 461 GHz. So the 461 GHz, 4.61 GHz, and so that it doesn't necessarily indicate to chip binning, but more so enhancing cooling factor. More importantly, though, these numbers are enough to beat the recently launched Snapdragon X2 Elite Extreme, which scored around 4,080 points in the single-core Geekbench test, meaning the M5 in the given the iPad is faster, and thus using the official Qualcomm numbers. Moreover, compared to the M4, the new M5 is almost 10% ahead of single-core performance and around 50% faster in multi-core performance versus the new M4 MacBook Pro listing on Geekbench. Compared to the PC chips, the M5 is only behind a new single-core listing on Geekbench if you count the best result, in which makes sense considering how there's literally only one MacBook Pro score right now, and it's quite cherry-picked. This also serves as a disclaimer for taking all these numbers with a grain of salt, since the sample size is simply too low at the moment to jump to any conclusions. Intel's Core i9 14900 kilo scores 4,457 points in the single-core test, making it 4.6% faster. The current gen Core Ultra 9 285 kilo isn't far from at 4,306 points, rendering the M5 only about 1% slower. AMD's fastest chip on the Geekbench is actually the mid-range Ryzen 5 76,000 with 4,226 points. But that test is deemed invalid. Therefore, both the 9950X and the 9800X3D take the top spot with the 3,616 and 3,615 points, which is the M5 comfortably best. M5 and PC chips, Geekbench's average. Apple M5, AMD Ryzen 9 99550X3D, AMD Ryzen 9950X, Intel Core i9 14900KS, Intel Core Ultra 9 285K. The two multi-threaded performance though the M5 gets absolutely shredded across the board. That's because it simply doesn't have enough cores to stack up to the AMD and Intel flagships. However, this could change the higher spec, the 14-core M5 that hasn't tested yet, and we assume the M5 Pro M5 Max will certainly help it level the playing field in this regard. The table above uses numbers of Geekspan processors benchmarks database to paint a more accurate picture alongside the extreme differences we mentioned earlier. Next one is Intel Foundry secure contract to build the Microsoft Maya 2 next-gen AI processors on 18A, 18A-P node client report could be first step in ongoing partnership. Microsoft and Intel announced their partnership last year, when Intel and Microsoft announced their plan to build a custom processors on Intel's 18A fabrication process in early 2024. Neither of the companies even hinted at the purpose of the silicon, leaving a lot of space for guesswork and interpretation by industry observers. Today, the semi-accurately reportedly broke the silicon the silence about the Intel Foundry's 18A foundry customers, depositing that the Intel Foundry IF is on track to produce an AI processor on 18A or 18AP for Microsoft. So far, Intel Foundry has officially landed only one major extreme customer for its 18A manufacturing technology, which is Microsoft. But while we tend to think about Microsoft as cloud and a software giant, and the company has quite a potential hardware development, or at least hardware definition team that builds custom silicon for a variety of data center applications, including Cobalt CPU, DPU, and Maya AI accelerators, to the name some. As it turns out, one of the Microsoft next generation AI processor will reportedly be made by Intel Foundry. If true, the deal would give Microsoft access to a US-based chip supply chain that is exposed to the capacity constraints that we see with both chip manufacturing and advanced packaging at TSMC. Additionally, the deal could be seen as a flavor to the Microsoft in other ways, given US government investment in Intel. For the lack of details, we can only speculate which of the next generation Maya processors will be produced by IF, Intel Foundry, but this would be a big development for Intel. Since we are dealing with a data center grade silicon, we are talking about the processor with a fairly large die size. Hence, if they are on the track to produce at Intel Foundry, then the company's 18A or 18AP with the 8% higher performance fabrication process is projected to be good enough to not only follow Intel itself, which is on track to ramp HGN 6 Plus Clearwater Forest in 2026, but also follow its foundry customers. The contract could be a sign of a good yield on Intel's node. Yield would have a significant impact on a large processor like Maya, meaning the Microsoft have likely opted for using the product based on a smaller die instead of if the word yield issued with the Intel node. Microsoft original Maya 100 processor is massive 82 millimeter cube millimeter squared piece of the silicon that packs 105 billion transistor, and which is larger than NVIDIA H100 and for 814 millimeter squared or B200, B300 computer chiplet 750 millimeter square. While the lion's shares of Microsoft Edge offering the full AI turn on NVIDIA's AI accelerators, so that the company is investing a lot to co-optimize its hardware and software to achieve a higher performance and increasing efficiency, and thus lowering the total of the total cost of ownership. As such, Maya is an important project for Microsoft. Assuming the Microsoft AI processor to be made by the Intel Foundry continue to the nearly electrical sized compute die, then the Intel's 18A manufacturing processor is on a track to achieve a defeat density that is low enough to ramp such chips with decent yield. So of course, the Microsoft could partition each next-gen AI processor into several smaller computer chiplet linked, though the EMIB or the Favelos technology, but they could impact performance efficiency. So we are most likely talking about the big or dies close to electrical size of the tools, which is 858 millimeter squared. To de-risk such a large component, Intel and Microsoft are almost certainly running a TTC loops where the Intel turns transistor and metal stack primers for Maya's workloads and performance target. In addition, Microsoft could embed spare computer coverage and redundant MHC Mac blocks into a macro block or Mac block, MH blocks into next-gen Maya layout to enable post-manufacturing fusing or repairing, which is what companies like NVIDIA do with their designs. Meanwhile, the big question is what exactly Intel Foundry will produce at Microsoft when, based on the last rumors, Microsoft is currently working on the next generation codenamed Braga Maya 200 processor that will use the TSMC 3nm node and the HBM4 memory, supposedly due in 2026, as well as the Clea Maya 300 Durate. Okay, next one is about the TSMC. Moves about 2nm production plants in Arizona. CEO also hints at further site expansion beyond the $165 billion commitment. Strong AI data center demand is pushing TSMC to build faster. The Taiwan semiconductor manufacturing company TSMC CEO C.C. Wei has said that it's moving up its 2nm production plants in Arizona due to the continued strong AI demand from its American customers. So he has also mentioned about the company is close to acquiring another massive property close to its latest fab in the U.S., hinting it is possible further expansion aside its current $165 billion commitment, according to the Nikkei Asia. We are preparing to upgrade our technologies faster to end-to-end more advanced processes in Arizona, given the strong AI-related demand from our customers, Wei said during a company earnings call. He also commented on the land acquisition. Our plan will enable TSMC to scale up to an independent GigaFab cluster in Arizona to support the need for our leading-edge customers in smartphone, AI, and HPC applications. TSMC had previously slowed its global plans because the demand wasn't there, but it has accelerated development of the Arizona fabs because of the robust demand from each US-based client. Construction of each N2 fabs in the site just started in April of this year, but it has already accelerated work on the site. The company initially expected the chip production to begin by 2030, but this announcement will likely bring it up by around a year, although the company hadn't mentioned a specific timeline yet. So aside from that, the planned land acquisition hints at the TSMC plan to turn its Arizona fab into a self-contained semiconductor manufacturing facility that can output 100,000 12-inch wafers monthly. This means that having on-site packaging and testing alongside the fab, with nearly supply chain partners and talent pipeline. In fact, the company has already begun working on developing future workers with the Arizona internship program, which has grown from the 130 to 200 slots. The company is confident about demand along the latest cutting-edge chips despite the growing uncertainty in the global semiconductor supply chain caused by the U.S.-China trade war. The multitude of announced deals and the partnership to build the data centers means that there is strong multi-demand for chips from NVIDIA, AMD, and Broadcom. There are also demand from the customer side, especially as Apple, another major TSMC customer, has just announced the arrival of the 5th generation Apple Silicon. Next one is the multiple generation of Intel's modern C chips see price hikes up to 12 overseas. Foreign markets are feeling the pinch, and 12th, 13th, and 14th gen chips. And the new CPUs aren't necessarily better CPUs. The recent report to indicate that Intel is purportedly increased the price of its 6th and 13th generation Raptor Lake and 14th generation Raptor Lake refresh processor by as much as 10%. While this adjustment may be applicable with the US market, the international markets are experiencing a rise above the 12%. Although the initial report correlated the price hikes, especially with the Raptor Lake, as the price increase also extends to a 12th generation older Lake processors. 다 나와. via Haruka 5719 renowned Korean pricing tracking and comparison platform shows the cost of the Core i3 and 14100F has escalated by 15% by the late September to the mid-October. Concurrent the price of the about the price is covered the fifth. Core i5 is the 14600KF and the Core i5 is the 12400F has been risen by the 13 and 15% respectively. Additionally, the cost of the Core i5 14400F has increased by 6. A similar price increases have occurred in the Japan market. The new Zared Gazgalog GAZ LG reported that Core i30 and 14100 and Core i30 14100F are selling for 10% and 2.6% more, respectively. Meanwhile, the popular Core i5 is SKUs such as the Core i5 14400 and the Core i5 14400F increased by the 12 and 11% respectively. The higher-end SKUs, particularly those from the Core i7, Core i9 lineups, have minor price fluctuation of around 5%. Intel 12th, Intel 13th, Intel 14th generation processor price hikes. Although the Core Ultra 200S, the codenamed Arrow Lake processor, have been available on the market for some time, there likely remained considerable demand for the previous generation processors. Subpar performance related prices has then differed consumers from adopting the Intel Arrow Lake series. A significant aspect of the Intel's Arrow of the marketing strategy have heavily emphasizes AI. Yet it is evident that not all consumers are fully expecting to compare enough to justify the upgrading to Arrow Lake. Increase the price for the Alder Lake and the Laptop Lake and may potentially enhance the Intel profit margin. The chip makers manufacturing these chips using the Intel 7 nanometer node, which is now fully matured and likely operating at full capacity. Conversely, Arrow Lake relies on a variety of external processor nodes supplied by TSMC, so there is limited wiggle room for pricing and flexibility. Therefore, instead of lowering price for a low Lake, it will phase over to Intel to elevate the price for processor produced in each in-house node, which is really tied to control. Arrow Lake prices have improved since the launch. However, we suspect that its sales are not exceptional. Intel has increased new price across the entire Arrow Lake of the Laptop Lake product lineup. Instead of it's done so exclusively for strategic SKUs, particularly the most popular mid-range SKUs, such as the Core i5 and 14400 and the Core i3 14100. After these categories, SKUs generate the highest the volume for Intel likely, which likely extending they are those experiencing the most significant price increase in the international markets. Texas Instruments on its path to 95% in-house manufacturing by 2030. An exclusive interview with the TICM's president on growing international capacity with in-house fabs and design agility, plus its plan in India. On its mission to increase self-reliance in semiconductor production, Texas Instruments has set a target to growing its internal manufacturing capacity to more than 95% by 2030. Stefan Bruder, the president of Texas Instruments Europe, Middle East, Africa, and India, EMEA, and said the company is investing in the facilities across multiple regions to deliver a geopolitical dependable capacity. Capacity, as the Stefan Bruder, president of Texas Instruments EMEA, credited, you need a free flexibility as the future is uncertain. Bruder told EE Times in exclusive interview. That is why we are investing in our manufacturing, aiming to outgrow our internal manufacturing to more than 95% by 2030. We have a manufacturing site in different global locations, and we run them with dual flow capabilities. This allows us to switch production between the locations to ensure the continuously and adapt in a world that is ever-changing. In June 2025, TI updated its long-term plans, which allocated more than $60 billion in 7 fabs being invested in since 2021 across the 3 U.S. mega sites in Texas and Utah, including up to $40 billion at its new 300mm site in Sherman, Texas. The company said the combined project could support over 60,000 jobs. TI concurrently operated 300mm fabs in Richardson, Texas, and Leahy, Utah, among 15 manufacturing sites globally. Customers including Apple, Ford, Medtronic, and NVIDIA, and SpaceX. The expansion comes as TI looks to strengthen its global position against the growing competition from Chinese manufacturers of foundation lower-end chips, while also meeting rising end demand for semiconductors that probe vehicles, smartphone data center, and TI's approach extends beyond the factors to include raw material procurement. The company tried to source materials locally in the region, managing manufacturers, which Bruder said it helped improve the self-resilience and reduce the dependence on other areas. The AI strategy. The Bruder said that TI's work on artificial intelligence spans on both large centers and edge devices. AI data centers are highly power-intensive. Our gallium nitride product increased power efficiency and lowering data center energy use, he claims. Gallium nitride technology is also gaining traction with a compact charger for phones and portable devices among the first application globally. Customers are looking closely at the gallium nitride for the efficiency and smaller form factor it provides, Bruder said. At the same time, TI embedding the AI capability directly into device. For example, our C2000 family of the real-time microcontrollers has embedded central network capability, suited for detecting sparks in solar inverters, making it easier for device makers to integrate AI at the edge. Many of these innovations he confirmed are being developed by TI in India, one of the most largest R&D hubs in collaboration with the TI Global design and manufacturing teams, engaging with the Indian market. India is central to this strategy, both as a design hub and growing customer base. Bruder noted that about 20% of the world's engineering population is based on India. This is one of the reasons that we started our engagement here 40 years ago. We want to leverage this by doing production design and also engage with the customers. That engagement extended to the talent development program. TI learns of the women in a semiconductor and a hardware program, WISH, which for a second year female engineer student, which concluded the first edition in 2025 with over 1,500 registration and 190 participants. The program combined 3 weeks of online mentoring with the final week of TI's Bengaluru campus, including lab visit, project, and sessions with the company engineers. Bruder said the program is part of the TI effort to draw young engineers into semiconductor field, whether it's product design and sales roles. India, he added, not only a source of talent but also expanding market. India is one of the largest economy worldwide. Is one of the largest economy worldwide. Has been growing fast. With the multinational corporation investment in India in leveraging its design and engineering capability, as well as many local companies that are very active. Those are customers we are engaged with. Innovation for local needs is next time. Thank you for your time. See you next time.